August 31st, 1922. A former railroad fireman named Harold Hamilton files incorporation papers in Cleveland, Ohio. His new company, Electro-Motive Engineering Corporation, has no factory, no product line, no employees beyond a handful of dreamers working out of a hotel room with borrowed furniture. The steam locomotive industry doesn't notice. Why would it? Alco, Baldwin, and Lima have been building locomotives since the 19th century. They control 100% of the American market. Their factories employ tens of thousands. Their engineering departments have designed the most powerful machines in human history. Steam power isn't just dominant, it's permanent. Or so everyone believes. 65 years later, Electro-Motive division will have destroyed them all. Every single one. EMD will control over 70% of the North American locomotive market and become the largest diesel locomotive manufacturer on Earth. The steam builders will be memories, their factories demolished, their names surviving only on museum plaques and in the memories of aging rail fans. Then something remarkable happens. EMD starts doing to itself what it did to Baldwin, what it did to Alco, what it did to steam. It starts dying. To understand EMD's rise, you have to understand what they were fighting against. In 1922, steam wasn't just technology, steam was religion. Every major railroad in America ran on it. Every locomotive shop in the country was built around maintaining it. Every engineer, every fireman, every mechanic. Their entire careers, their entire identities, depended on the thundering machines that had conquered the American continent. And Harold Hamilton? He wasn't even building locomotives. He was selling gasoline-powered rail cars, doodlebugs, the industry called them with a sneer, cheap little self-propelled passenger cars for branch line service where real trains weren't worth the expense. Nobody important, nothing threatening. But Hamilton understood something the steam aristocracy didn't. He understood where technology was heading, and he understood business better than any railroad mechanical officer in the country. EMC had no factory, so Hamilton partnered with specialists. General Electric provided electrical systems. St. Louis Car Company built bodies. And a Cleveland company called Winton Engine provided the power plants, distillate engines that could run all day without the constant attention that steam demanded. The partnerships worked. EMC's railcars earned reputations for reliability. Railroads that bought them kept buying more. General Motors noticed. In 1930, GM bought both Winton and EMC within months of each other. The automotive giant wasn't interested in railcars, they were interested in diesel engines, and they were interested in replacing every steam locomotive in America. Charles Kettering, GM's legendary research director, had been experimenting with two-stroke diesel engines in his laboratory. His team achieved something that should have been impossible: the same horsepower from an engine 25% smaller with a 20% weight reduction compared to conventional designs. The engineering wasn't incremental, it was revolutionary. In 1934, that engine powered the Burlington Zephyr on a run that captured the nation's imagination. Denver to Chicago, 1,015 miles, 13 hours and 5 minutes, nonstop. The streamlined stainless steel train averaged 77 miles per hour, hitting a peak of 112. Newspapers across the country ran the story on their front pages. The public fell in love with the sleek machine that looked like the future. GM built EMC, a factory in Grange, Illinois. 1 million square feet of manufacturing floor space on 383 acres. Production began on January 2, 1936, when the frame for Santa Fe Switcher 2301 was placed in the main assembly bay. By April, 350 workers were busy. By May, the first locomotive rolled out for christening with a bottle of ginger ale. The streamlined age had begun. But passenger trains were the easy part. The real money was in freight. And freight meant replacing thousands of steam locomotives pulling millions of tons across America every day. No diesel had ever proven it could do that job. The steam builders were certain it never would. Steam locomotives had a century of continuous improvement behind them. The biggest freight engines, articulated behemoths with 16 driving wheels and fireboxes the size of small houses, could haul anything. They were temperamental, yes. They required constant feeding of water and coal. They needed armies of maintenance workers at every division point, but they had power that diesel advocates could only dream about. Then, November 25, 1939 changed everything. That's when EMC quietly released demonstrator set number 103 from Grange. 4 units coupled together, 5,400 combined horsepower. They called it the FT locomotive, and nobody, not even EMC's own engineers, knew exactly what they'd created. Over the next 11 months, the FT toured 20 Class 1 railroads across 35 states, covering 83,764 miles. And everywhere it went, it didn't just match the best steam locomotives, it destroyed them. On the Santa Fe, the FT hauled freight through Arizona desert grades that required multiple steam helpers. On the Baltimore and Ohio, it climbed Cranberry grade twice as fast as 3 massive mallet compounds working together. On the Boston and Maine, it moved 95% more tonnage between Boston and East Deerfield than their best steam power could manage. But the numbers that killed steam weren't about power. They were about availability. A steam locomotive needed water every 100 miles, coal every few hundred more, roundhouse attention at every division point. The infrastructure to support a single steam locomotive cost more than most railroads realized. Water towers, coaling facilities, ash pits, turntables, roundhouses, armies of workers shoveling and oiling and inspecting. A steam engine that worked hard was lucky to see 500 hours of service per month. The FT demonstrator? Fuel it and run it. During its 11-month tour, the 4 units averaged over 95% availability. They ran when railroads needed them. They didn't care about water stops or coal facilities. They didn't need turning at terminals. They just worked. By October 1940, when the demonstration was over, 16 railroads had already placed orders. The diesel revolution wasn't coming. It had arrived. World War II should have stopped the dieselization of American railroads. The War Production Board restricted locomotive construction to proven designs, and steam was proven. The traditional builders, Alco, Baldwin, Lima, were ordered to keep building steam to meet wartime traffic demands. But EMC got an exemption. The Navy needed diesel engines for submarines and landing craft. EMC's 567 engine, the power plant that drove the FT, was perfect for marine applications. The War Production Board let EMC continue diesel locomotive production as long as they prioritized military orders. While the steam builders cranked out wartime power that would be obsolete within a decade, EMC refined their diesel technology with Navy funding. In January 1941, General Motors reorganized. Electro-Motive Corporation merged with the Cleveland Engine Operations to form a single entity, the Electro-Motive Division of General Motors, EMD. The name would become synonymous with American diesel power for the next 60 years. The war years were brutal for railroads, traffic doubled, equipment wore out. But the FTs that had been delivered before restrictions tightened proved their worth daily. Railroads that had received diesel power watched their operating ratios improve while steam-dependent lines struggled. The economics weren't theoretical anymore. They were visible in every accounting department in the industry. When the war ended, EMD was ready. The Grange factory that had been building submarine engines retooled for full locomotive production. By 1947, the plant was shipping 4 to 6 locomotives per day. Railroads that had waited years for diesel power could finally order what they wanted. What they wanted was everything EMD could build. The steam builders never had a chance. Alco tried. They'd been building locomotives since 1901, the result of a merger of 8 smaller companies that controlled most of American steam production. They had the engineering talent. They had the manufacturing capacity. They had relationships with every major railroad in the country. What they didn't have was the right diesel engine. Alco's 244 diesel looked good on paper. 2,400 horsepower from a turbocharged design that promised to match anything EMD offered. But the 244 was rushed to market before proper testing. Within months of entering service, the problems cascaded. Crankshafts cracked, turbochargers failed, cooling systems leaked. By 1948, Alco had spent $4,300,000 on warranty repairs, roughly $55 million in today's money. Their reputation was shattered. The improved 251 engine came too late. By the time Alco sorted out their problems, EMD owned the market. Railroads that had given Alco a chance in the late 1940s had learned their lesson. They weren't risking their operations on unproven equipment again. Baldwin's story was even sadder. They'd been building locomotives since 1831, the oldest locomotive manufacturer in America. But Baldwin's management never believed diesel would succeed. They built diesels reluctantly, treating them as a temporary fad that would pass once railroads came to their senses. Their locomotives reflected that contempt, underpowered, poorly designed, maintenance nightmares. By 1956, Baldwin was out of the locomotive business. They tried pivoting to other heavy equipment, But the company that had built more steam locomotives than anyone else in history couldn't survive the transition to diesel. The last Baldwin diesel was delivered in 1956. The company limped along until 1972, when the final corporate remnant was dissolved. Lima merged with Baldwin in 1950, a desperate combination of two failing companies. Lima Hamilton, as the merged entity was known, built a few hundred diesels before being absorbed by Baldwin in 1951. The name that had created some of the most magnificent steam locomotives ever built, the Berkshires, the Alleghenies, disappeared into corporate oblivion. Alco held on longest. Their 251 engine was actually competitive with EMD's 567, and they found a niche building locomotives for railroads that wanted an alternative to the Grange monopoly. But the 244 disaster had poisoned their reputation. Orders dwindled. Market share collapsed. In 1969, the American Locomotive Company built its last locomotive and exited the business entirely. Three companies that had dominated American railroading for generations. All of them destroyed by the startup from Cleveland. By 1965, EMD controlled over 70% of the North American locomotive market. They had become exactly what the steam builders once were: untouchable. The warning signs appeared in 1963. General Electric, which had been supplying electrical components to locomotive builders since the dawn of dieselization, decided to compete directly with EMD. GE's U-25B was a crude machine compared to EMD's refined products. Early units suffered reliability problems that reminded some observers of Alco's 244 disaster. But GE had something EMD had forgotten how to use: humility. They listened to customer complaints. They fixed problems rapidly. They improved their designs with every production run. EMD's response to GE's challenge revealed what the company had become. Instead of focusing on reliability, the quality that had made them dominant, EMD chased horsepower. If GE was building 2,500 horsepower locomotives, EMD would build 3,600. The SD45, introduced in 1965, was a 20-cylinder monster that pushed the 645 engine platform beyond its design limits. On paper, those extra 4 cylinders looked magnificent. 600 more horsepower than the 16-cylinder SD40. Enough power to challenge anything GE could build. In reality, the SD45 became EMD's first major mistake since the founding. The 20-cylinder engine's crankshaft was so long it had to be built in 2 pieces, bolted together in the middle. Under full load, the crankshaft flexed. Stresses concentrated at vulnerable points. Failures cascaded through the engine. Some railroads kept spare power assemblies on hand, expecting to swap them into disabled SD45s like replacing batteries. Meanwhile, railroads that had ordered the less glamorous SD40 noticed something strange. Their 16-cylinder locomotives were doing the same work as the SD45s, burning less fuel, and staying out of the shop. The SD40 wasn't as impressive on specification sheets, but it delivered 3,000 horsepower with the reliability that had made EMD dominant. The market noticed. By 1970, the lesson was clear. Raw horsepower meant nothing if you couldn't keep the locomotive running. January 1972, Kansas City Southern 637 rolls out of Grange, the first production SD40-2, beginning the most successful locomotive program in American history. The SD42 wasn't revolutionary, that was the entire point. EMD took the proven 16-cylinder 645E3 engine that had made the SD40 a workhorse. They lengthened the frame to accommodate improved HTC trucks with better adhesion. They incorporated modular solid-state electronics that made troubleshooting dramatically easier. Plug-in modules that technicians could swap in minutes instead of hours spent tracing wires. 40 improvements in total, most of them invisible to casual observers. What emerged was a locomotive that represented the state of the art without bleeding-edge risk. Every component had been proven in service. Every system had been refined through years of operational experience. The SD40-2 wasn't trying to push boundaries, it was trying to be exactly what railroads needed. Nearly 4,000 units were built between 1972 and 1989. Burlington Northern alone ordered over 800. The locomotives became so ubiquitous that some railroads standardized their entire fleets around them, one model for every assignment, with parts interchangeability that slashed inventory costs and training requirements. The SD42 didn't just survive the crisis that was killing American railroads in the 1970s, it helped save them. Penn Central's bankruptcy, Rock Island's collapse, Milwaukee Road's death spiral. The industry was fighting for survival, and survival required locomotives that worked every day without drama. The SD42 worked. It started every morning, ran every mile, and came home every night. For 50 years. Some units are still hauling freight today, older than most of the employees working alongside them. That was EMD at its absolute peak. A locomotive that was good enough in all the right ways, not the most powerful, not the most sophisticated, just perfectly balanced for what railroads actually needed. Then EMD made the same mistake again, and this time, they didn't recover. By the mid-1980s, GE had finally caught up. Their Dash 8 series used microprocessor controls that dramatically improved reliability and fuel efficiency. In 1987, the impossible happened. GE passed EMD in North American market share. The company that killed steam had been overtaken by its own former supplier. EMD's response defines everything that went wrong afterward. Instead of returning to the reliability focus that had made the SD40-2 legendary, EMD chased horsepower again. If GE was winning with 4,000 horsepower, EMD would build 6,000. The SD50 had already failed, a 3,500 horsepower locomotive plagued by reliability problems that made some railroads rate it worse than the SD45. But EMD pushed forward anyway. In 1995, they announced the SD90 Mac, 6,250 horsepower from a revolutionary new engine called the 265H. It would be EMD's first four-stroke design since the Winton 201A that had powered the original Zephyr in 1934. 60 years of two-stroke expertise, abandoned for an untested technology. Union Pacific signed contracts immediately. They were desperate for power to handle exploding coal traffic from the Powder River Basin. The promise of 6,000 horsepower from a single locomotive was irresistible. The 265H wasn't ready. When Union Pacific's orders came due, EMD couldn't deliver the engines they'd promised. Instead, locomotives shipped with 4,300 horsepower 710 engines, essentially SD70 Macs wearing SD90 Mac bodies. These convertible units were supposed to be upgraded later when the 265H was perfected. The upgrade never happened. When the 265H finally entered production in 1996, the disasters began. Crankshaft failures, cooling system collapses, cylinder problems that shut down entire engines. The 6,000 horsepower marvel spent more time in shops than on main lines. Union Pacific crews started calling them boat anchors. Less than 70 SD90 Mac H locomotives were ever built with actual 265H engines. Union Pacific eventually returned theirs after the leases expired. The most powerful single-engine locomotive EMD ever created became an embarrassment that accelerated the company's decline. The 265H wasn't a bad design, it was a design that wasn't ready. Sound familiar? GE made the exact same mistake at the exact same time. Their AC6000CW, introduced alongside the SD90 Mac, promised 6,000 horsepower from a German-designed 7HDL engine. The partnership with Deutz MWM seemed perfect. German precision combined with GE's locomotive expertise. Together, they would dominate the high-horsepower market before EMD sorted out their problems. The 7HDL was a disaster. Engine block walls too thin, resonant vibrations that built up near operating speed and propagated through the entire locomotive, turbocharger failures, cooling system problems, brand new $6 million locomotives shaking themselves apart. CSX and Union Pacific received the first units. CSX crews reported vibrations so intense they preferred running two 30-year-old SD42s over a single AC6000CW. Union Pacific ordered convertible units with smaller proven engines, planning to upgrade when GE fixed the problems. GE fixed the problems. That was the difference. When the 7HDL failed, GE threw resources at the engineering challenges. They redesigned the engine block. They solved the vibration issues. They developed the Gavo engine that would power their next generation of locomotives. It took years and hundreds of millions of dollars, but they survived. EMD had none of that capability. General Motors was bleeding cash from automotive operations and saw the locomotive division as a distraction. Engineering budgets got slashed exactly when they needed to be expanded. Quality control collapsed. The SD90 Mac disaster festered while GM executives looked for someone to take the problem off their hands. Both companies made the same mistake. Only one had the resources to recover from it. In June 2004, the Wall Street Journal reported that General Motors was putting EMD up for sale. After 75 years as a GM division, the company that killed steam was being discarded like last year's model. The sale closed on April 4, 2005. Private equity firms Greenbrier and Berkshire Partners paid an undisclosed amount for the newly renamed Electro-Motive Diesel, Incorporated. The legendary EMD initials survived, but the connection to General Motors was severed. 5 years later, Caterpillar's Progress Rail subsidiary bought EMD for $820 million. The company that Harold Hamilton founded in a Cleveland hotel room was now a subsidiary of a heavy equipment manufacturer. But the real death wasn't corporate, it was physical. In 1991, EMD had moved locomotive assembly from Grange to London, Ontario, a union-friendly Canadian plant that had been building locomotives since 1949. The Grange facility continued producing engines and components, but Plant 1, where the FT was born, where the SD40-2 rolled off the line, where 14,750 locomotives were assembled over 56 years, went silent. In 2000, Plant 1 was demolished. Workers who had spent their careers inside those walls watched bulldozers tear down the building where American railroading was transformed. In 2012, Progress Rail closed the London plant after a bitter labor dispute. Workers had refused to accept 50% pay cuts. Caterpillar's response was to shut down the facility entirely and move production to Muncie, Indiana, and contractors in Mexico. In 2018, even engine production left Grange for North Carolina. The massive complex that had once hummed with the construction of America's mightiest machines fell quiet. Today, EMD's former 383-acre Grange site is partially vacant. Some of the land is occupied by warehouses. The huge Electro-Motive division sign that once stood at 55th Street and East Avenue has been removed to the Illinois Railway Museum, where it joins the preserved locomotives that represented EMD at its peak. The home of the diesel locomotive is gone. Here's the truth about EMD in 2025. The company still exists. Progress Rail still builds locomotives with the EMD badge. The SD70ACE-T4, introduced in 2015 to meet EPA Tier 4 emission standards, uses a descendant of the two-stroke engine that traces its lineage back to the original 567. The DNA that powered the FT demonstrator in 1939 still runs through locomotives, rolling off the Muncie assembly line. But EMD holds roughly 30% of the North American market. GE, now Wabtec, after its own corporate transformations, controls approximately 70%, the exact inverse of EMD's peak dominance. Drive along any mainline railroad in North America, and you'll still see EMD power working. SD42s that have been hauling freight since the Nixon administration, SD70 Max that replaced the failed SD90 Max, thousands of locomotives wearing the EMD badge, earning their keep the way EMD power has earned its keep for 8 decades. The two-stroke diesel engine that EMD perfected remains one of the most successful industrial designs in history. The 710 engine that evolved from the 645, that evolved from the 567, that evolved from the Winton designs of the 1930s, that fundamental technology still moves American freight. But dominance? That's gone forever. EMD's story is really 3 stories. First, it's a story of revolutionary transformation. A startup with no factory and no products destroyed an entire industry through superior technology and relentless execution. EMD didn't just compete with steam, they eliminated it. 3 centuries of steam locomotive development wiped out in 20 years by a company that had existed for less than a generation. Second, it's a story of engineering perfection. The SD40-2 represents what happens when a company truly understands its customers. Not the most powerful locomotive, not the most sophisticated, just exactly what railroads needed, delivered with reliability that lasted generations. Over 50 years later, those locomotives still run. That's not marketing, that's engineering. Third, it's a story of hubris and decline. The same company that patiently developed the FT through years of rigorous testing rushed the 265H to market before it was ready. The same company that built its reputation on bulletproof reliability chased horsepower numbers that looked good in catalogs, but failed in service. The same discipline that created the SD42 disappeared when EMD needed it most. EMD didn't fail because of external competition. GE's rise happened because EMD gave them the opening. The SD50's problems, the SD90 Max disaster, the 265H's failure. Each mistake was self-inflicted. Each mistake could have been avoided by remembering what made the company great. General Motors could have invested in EMD's future. Instead, they sold it to private equity that had no interest in locomotive engineering. Caterpillar could have rebuilt the company. Instead, They closed the factories that had built American railroading and moved production to wherever labor was cheapest. Harold Hamilton started with nothing in 1922 and built an empire that destroyed century-old companies. His successors inherited that empire and watched it crumble. The locomotives he created changed America. The company he founded almost didn't survive its own success. They called it Electro-Motive Division. They should have called it a warning.